Hi, my name is Dan, and this video is one of a long series of videos in which I go through and chart the process of taking digital logic gates and combine them together in all sorts of clever ways in order to make a 4-bit working programmable CPU. It's been quite a long ride. And if you've been playing along with me, well done for getting this far. And a roadmap of where we've been mostly is in the description down below, as is a link to where you can get hold of this software, which is DigitalWorks, is free software for simulating digital electronics. And the stage that we're at now is we're in the last playlist out of quite a few. And in this one, we're putting together the CPU. In fact, we've now actually put together all the components that make the CPU and make it work. In this video and the next video, we're going to be putting in some stuff that means we're able to enter programs and control it. But this, at this point, is a working CPU, or should be. So before, in this video, we're going to do the manual data entry. Sorry, I've just got an extra component that snuck in there. In the last video, I did say that we're going to do the control in the next video, but that I got my orders wrong. We're going to do the manual data entry, and then the next video, we're going to do the controls. And then finally, in the video after that, we're actually going to do some programming and hopefully test this out and see if it works. This is quite monumental. At this point, actually, before we do that, there's something that we haven't done, which is done anything about the template editor. We're not actually going to use this as a macro to put in anything else. There would be no good reason for doing that. So the template editor is just going to have a box in case we ever wanted to put it onto something just for the sake of that. So this obviously was the template that we had for the ring sequencer, which is a few videos ago, and we're just going to call this CPU. Every good CPU has a name, which is usually maybe a couple of letters and some numbers, which kind of sounds very techy and codey. So I'm going to create a name for this CPU. Finally, after all this time, I'm going to give it a code name. And I'm going to call it, I'm going to start with a couple of letters and then have some numbers. I'm going to call it KF for complete fudge, and even more of a fudge because I'm spelling complete with a K because I'm cool with a K. And then because it's 4-bit, we're going to have four numbers here. And we might as well have a version number. So this is version number 1.0. We need the ability to expand if we want to go above 9 versions. So I'm going to call it 010. So CPU KF 4010. And that'll do quite happily for us. Okay. And let's save. So time to put in this the manual data entry stuff. And we're going to do this mostly through the buses, not entirely. And we're going to make sure we label everything very clearly. So we're going to want, in order to input data in, we're going to need to have the address register. And we're going to use the data input for the address register rather than the bus input. It just makes our lives a little bit simpler as a result. So I'm going to connect those up and put in an annotation. So manual address. And that's quite easy. We can then just use the data read here to make sure that that register holds that value. And we're going to do the standard thing over here using tri-state devices to be able to input some stuff over this side. But I'm going to, I'm trying to think how I'm going to lay it out best. I'm going to do it slightly differently from how I sometimes do it, which is just an easily copy and pastable method, I'm going to make them slightly different by staggering them in a different way. 3, 4. Could have those a lot closer together, but that means the enable line kind of gets fouled up. So I'm going to put how am I going to line them up? I wonder. 1. We'll have them spread out. It doesn't matter. 2, 3, 4, and that's going to be the data entry for anything that we want to put in the data memory. And we're going to have a similar set over this side for the op memory, which means I'm going to want that again, but I'm going to, I'm just thinking about space. We just don't have a huge amount of space over here. Partly as a result of taking all these wires up and over the top. I could create a bit more space, so let's do that. What I'm going to do in order to do that is I'm just going to pull these wires down to come as close as we want. And notice what I'm not doing is feeding this into the op and data registers, because that's not where we want it. We want it in the memory. And then it'd be pulled out from there into the op and data registers. Let's move that annotation to give us some space. Basically what I'm doing right now is I'm tidying up. My wife would be astounded. Right, and that gives us hopefully a little bit of space. Close the prop center down. I don't think we're going to need it. To put another set of tri-state buffers in. And we're going to turn those upside down. And stagger them again. Control and copy. That looks kind of reasonable. Maybe ish. Okay. And so I'm going to do inputs for them. Don't want it there, do I? I'll move it in a second. I want it kind of more like there, so it's coming down and then into there. Wire these up to the inputs. I haven't done the data one wiring it into the bus yet, so I need to do that. Now then, that's going to be 3. Now what I want to be is on this bus, but actually these wires are part of the bus as well. So I'm actually going to drop down to there. Just make sure I'm on 3. There we go. Oh, that's maybe a bit too much of a gap. I do have enough space to get this all in, thankfully. Right. I haven't put the enables in yet. I'll do that in a little while. Let's wire these up. So this is 0, so that needs to go to the far side. 1, 2, 3, and let's have annotations in. So this is manual data entry, and this is going to be manual opcode entry. It would have been nice to have all these bits together, but it really doesn't actually make sense to do so, I'm afraid. So we're not quite there yet. We've got enables to put on here, and we've also got to tell the memory that we're actually going to do a write. Which shall I do first? I will deal with the memory end first. So the op memory, what we need to do is we need to take the data off the bus. So that's bus read, and we want to write it to the memory. So we're going to use bus read and write. There is no reason not to wire those two together. We're going to be using one of these an input thing to actually make this happen. So I'm going to put that. I'm just thinking in terms of space and wires, but I want it near this. So I'm actually going to put it there, but I'm going to do some routing to make it work, and then I'm going to label that. So this is the thing that's actually going to make the write happen. Oh dear, I've got those enables there to deal with as well. Sorry about this. Squeaking wires in there in the spaces that we've got. Squeak that across to there. It's a bit cheeky. And then what did I want? I want bus read and write. So we do have that's closer than it needed to be, but that's fine. Right, and bus read. And I'm going to label that and call it writes to op memory. Okay. So what we do when we're in manual data entry mode, and we haven't done the thing that sets that mode yet, is that we put a value in here, and then when we want it to, and make sure we've got the right address here, and so to write that opcode into that address in the op memory, we hit that button, which then hits bus read and write. And we want the similar thing across here for from the data bus. However, this is slightly trickier because we already have wires coming into bus read. Bus read and write on the data memory bank, and so we're going to have to reroute these and feed them in using OR gates. So we've got an OR gate coming from that one and an OR gate coming from that one, and then our connection to actually write to the data memory, which we might make up there, needs to connect up with those both. And the space to chuck a couple of OR gates in there is quite limited. So let's do it down here. And we're actually going to set them up right and then bring things around behind the space is getting quite limited now, as you can tell. And a fairly easy way to do this is to wire off the bridge read. I'm just thinking through this, and take this round. Which one I'm going to take where? I'm going to go to this one first. So what I'm not doing is wiring up to the output because it won't let me, because that'll be two outputs connected together. But I've basically extended that line out, which is where I'm going to want to reroute it to, down to here. And then I need to remember that this is the one that I'm doing, and delete. I can now delete that little bit. And the one thing I wanted to avoid is deleting this whole wire, because I then have to redo it all. And so I'm coming from here, across to that bus read there. I will need to do the same thing for the right, and again, space is going to get slightly tight here, but I am going to be able to sneak it through. Bring that down around, and bring it around to that one there. Then I'm going to do the same thing as I did there, which is to disconnect this one. Somehow I've got to get a wire in to there. There is just about a gap there that I can do. Oh, I've connected it to the thing above. This is sometimes the problem that you have when you've got wires that are so close together. Let's try doing it from this end first then. Yes, it's given me an angle there. Ooh, squeaky, squeaky. Kind of online there, and I don't want to do that. So, unable to connect two outputs. I'm having problems because everything's so tight. Let's see if I've got an alternative here to getting that in. I'm just kind of looking at spaces going in this direction. Right, I'm going to have to do a bit of a jiggle. So what I'm going to do is just take that up a tiny bit. Ooh, I don't like that. Tiny bit more. Bring it to this point and then take it up there and use this gap here. This will allow it. Yes. Wow. And then we need to wire up a control to those. All right. I'm going to take this all the way around here because I want that control to be very close to the manual data entry where you actually put the numbers in. I'm going to label that write to data memory. I'll put it down a bit, but really close to that, so it's clear that it's that one that we're using. That's so close to the edge of the screen, it's not real. Let's just take the whole thing. Ooh, Control C, that's not what I wanted. Control A. And now we can use the cursor keys just to edge everything across a little bit. Does that look better? I really don't know. So that's the controls to actually do the writing of the data. The thing that I indicated said that we're also going to need is a manual mode. And what that mode is going to do is it's going to do these output enables for this set. It's all getting quite confused down here, so I need to be careful about that. And for this set across here, and it's also going to go into data read on the memory address register. And the reason for that is that when we put the address in there, it will automatically always read that into the address when we're in that mode. So we just need to change the address. We don't need to have extra buttons to do things. These will be automatically connected to the buses. We need to make sure when we're doing the manual data entry that that we're not running. So this go needs to be off. Switch that off now just in case. And when we've finished manual data entry, we need to disconnect this because otherwise we'll get bus contention. And then if we get bus contention, the simulation will switch itself off. And once it does that, we lose all the data that we've put in the memory. So we don't want that to happen. So we've got a bit more wiring up to do, which is going to be the, I'm going to put one last control here. So this, I'm going to call this manual mode, or maybe even manual data mode, manual entry mode. Okay. If we're really clever, we'd wire this up so that it automatically switches off, and wire it up so that when we switch on, it automatically switches this off, but I'm not going to go to that complicated extent. So this needs to be data read, as I said, and we need to connect together all of these. And we're going, squeaking it over the top there. I can do that. That's okay. And that needs to connect to all the others. So I'm going to connect that across. Okay, and we need to connect that to this one here. So I'm going to, as I said, I'm feeling a bit crowded over this end. Oh, let's attach that to that, and then come down here, attach that to that, and the last one. Is that actually the right thing? Yes, thankfully. And we've got to attach across here as well. That's not in a place where I can do it, but that is, squeak it up over the top again. It has a kind of symmetry to it. There we go. So that should give us our manual data entry mode. Let's see if we can test that out now at this stage. We're not going to put anything meaningful in because we don't have a lot of controls yet, and I don't really want to test the meaningfulness of it. But I'm just going to how are we going to do this? Or do I need to do a reset? Let's do this anyway. So let's put manual data entry. Let's enter manual data entry mode. So the address is 0, and let's put 1010. So the bus is lighting up, which is what we want. And then hopefully when I hit that write to data memory, that has gone in there and we can see that value. We can check also whether we can do here. So let's put 7 in the op. And again, manual write to op memory. That should do 7. Okay. And then I'm going to do 1010 to both of them. But I'm going to change the address to 0001. And oh, I've already got write to data memory on. which I should have just disconnected. So what has actually happened is that I've overwritten the one that was in 0, 0, 0, because I didn't disconnect that. I'm going to write this to the op memory. Right, I'm going to put 1, 0, 1, 0 back in the 0, 0, 0, 0 position, and write to data memory. That should be there. Right, now I'm going to disconnect manual entry mode, and memory address register set to 0. Unfortunately, the program counter is currently set to 1111. So that's going to cycle around the end because we haven't put in a clear yet. That's going to be part of our controls we're going to do next time. But let's press go. So the first thing that it's going to draw out the op memory is probably going to be 1111, because that'll be up there at the top of the bottom of the memory physically. Then it should pull out 7, and then it should pull out 8, which is this 1000. And in the data, it should pull out 1010 first, and then 1000, which is what we put in the second one. Let's actually see if that happens. So the first cycle will be the one where the program counter is all ones, and so that won't do anything useful. On the second cycle, we've got 0111 there, and we've got 1010 come out here into the data. That's exactly what we expected. On the next cycle, we've got 1000 here, and have we got 1000 there? Oh, no, we haven't. We're into the next cycle now, which is all ones. Okay. It does seem to be working. We might not have put because of the manual data entry thing, that doesn't seem to have done exactly what we wanted. We haven't got the resets in, so we'll test this more later on, but it does seem to be doing something, and hopefully it's something useful. Certainly we saw both for the first address, we saw the correct information coming out for the data memory. That's the data memory. I should have been looking at the data register, which is there, but I haven't got a useful way yet of resetting all this counter, and I don't want to go all the way around again. So I'm going to stop waffling now and say in the next video we're going to add these controls that I've been promising, but that's it from me for now.